Hi, so we created a virtual reality ping-pong game where you play against an artificial intelligence, which you can also coach, which is to say, help it improve its performance as you play. We decided to develop the project using the Unity game engine because of its well-known VR support, as well as a newly created machine learning library, ML Agents, which links Unity with TensorFlow, the Python machine learning backend. Let me tell you a bit about how the development went. So, throughout the project, we used reinforcement learning. However, the first approaches weren't very successful. We tried to have the neural network control the racket's position and orientation fully, and the rewards that we gave for hitting the ball or making an accurate shot were simply not enough for the bot to figure out what it should be doing. So instead of playing, it was doing something like this. So it didn't work. We had to simplify the model. So in the final model, the neural network only decided the shot trajectory, and the rest was done automatically for it. So the racket automatically tracked the ball and tried to hit it, and then at the moment of collision, the machine learning module said what the shot trajectory should be. So that was independent of the racket's actual angle, so we clearly gave up on some realism to achieve the result we wanted. But we managed to get many improvements. We discovered curriculum learning, which is the idea of making the training environment more and more demanding as the training progresses. And we also implemented more complicated reward system. These improved our performance greatly. So this is how we pre-trained our opponents. How did we implement the coaching part? So we didn't use machine learning for that because that would require days and days of human playtime and to see any noticeable effects. We didn't have time for that. So instead, we used an additional layer of parameterized heuristics, which could intercept the output of the neural network and make their own decisions on top of that. The parameters were adjusted as the AI played against the player and learned from its mistakes. So for example, if the AI played the ball to the left and then the player hits it really hard and wins the point, then the AI in the future would be less likely to play to the left. You can see some heuristics there. However, as a proof of concept, we did write a data logging tool which can save human play data, which could enable us to perform machine learning, to train bots against humans using machine learning. If we had enough time and volunteers, we would be able to do that. Well, we didn't. Another place in which we gave up on some realism to achieve our goal was the physics of racket-ball collisions. So we decided not to model the ball spin to save some time and complexity. However, this meant that the basic elastic collision model between the ball and the racket didn't work well. It didn't feel realistic. So we settled for a simple made-up model, which we found worked well enough, where we simply give the ball the velocity of the racket plus some extra term for the normal vector. We created the game ourselves in a very big percentage. So we made all the models ourselves in 3D software called Blender. We used Unity to create and assign appropriate materials to make the models look pretty in the game. And we had the pleasure of using Oculus Rift, the VR headset. The integration of that with Unity was aided by Valve's Steam VR library, which let us quite easily implement looking around, controlling the racket, and using the main menu. In conclusion, the team learned a lot of technical skills from working with VR equipment through machine learning and writing your own AI. We also learned a lot about working as a team and integrating and coordinating our work in different aspects of the project. And we had a lot of fun. It was a very fun project. Thank you.